Most people have heard of the fact that computers talk to each other and process what they're supposed to do through a series of zeros and ones. The good news is, you don't need to know what those zeros and ones mean. When you double-click an application, it needs to do what you asked. Somewhere on your computer, there's a set of zeros and ones in a pattern that will do exactly what you asked. If the sound for a beep is 01010, then the application must somehow get the 01010 to run on the system. If your operating system changes and 01010 is no longer the binary pattern for a beep, then this legacy application might not run anymore. A legacy application only knows the calls that works on a specific operating system or specific chipset. If you updated your operating system, then this new operating system might expect a different set of calls to do the same task. At that point, the legacy application might not work. In the 90s, we saw many DOS applications that should have worked on Windows, but in reality, it had trouble. With .NET, the CLR, also called the .NET Runtime, will do all the talking to the operating system. Now, we do not refer to the .NET Runtime as a translator, but rather as a layer between the top layer and the bottom layer, which is the operating system. The .NET Layer CLR lives between these two other layers. As data moves to the CLR, it gets translated into calls that work for that particular operating system. In other words, we compile the code to the CLR, and the CLR is already installed on each machine. We only need one CLR to run all the .NET applications we want. Even if you get a new operating system, the calls from the application don't need to change. The .NET Runtime on the new system will understand the architecture of the operating system and make the correct calls. So if we have a .NET executable or application on a computer with the CLR, we're all set. But where do .NET programs come from? Let's go back to the 32-bit days for an example. When most of the traditional non-.NET applications are written, a compiler was there to convert the source code into an executable file. If we write our code using Notepad and save it as a text file, it's just a text file. If this text file contains a valid program instruction set, and we compile it using any valid compiler like C or C++, we will get back an application or executable. The compiler takes the source code and creates a new file with a file extension as exe. This can be executed like any other program or application. The source code file is converted into an executable in which the operating system, like Windows, can understand. Just like a construction team in Germany would probably have blueprints written in German, a compiler is also language-specific. For example, to turn C# code into a .NET assembly, we need a C# compiler. .NET applications have something very special. When the .NET application is compiled, it stores instructions in the Microsoft Intermediate Language, also called MISL. When C# code is run through the C# compiler, it generates an assembly in a universal language usable by .NET. In other words, MISL instructions are the same on all .NET computers, even if the operating system is completely different. Another way to say this is MISL is agnostic or does not care about the processor architecture or the operating system. The .NET assembly does not talk directly to the operating system or processor, but instead talks to the CLR. The .NET layer can then translate MISL to the specific operating system or processor language on any given computer that the CLR is installed on. When the native code of the computer runs, the user can see the expected effects. In this diagram, the Hello World exe has already been compiled into an application that speaks MISL code. The Hello World exe will get compiled by the CLR, and the assembly's MISL instructions will be turned into native code for the OS to run. This is known as JIT compilation. JIT stands for just in time. It is this native code that is specific for a particular operating system and processor architecture. It does not matter to the assembly if the call should be 001 or 1010. The call to the OS will take care of that. There are thousands of things that can be done on our computer, like write a letter, open a chat connection with friends, save pictures of the hard drive. So if .NET wants to make a call, to beep, to flash, or to save a file, it needs to have a library of methods and classifications. The .NET Framework Class Library is a collection of reusable components for the programmer to build advanced applications without having to know the computer's native code. The FCL helps developers to write different types of applications. An example can be Windows applications, web applications, or even services. The FCL already knows what a web address looks like, how web ports work. Therefore, a lot of common functionality is already written into these libraries, so a developer can simply use these classes. And that will do it for Lab 1.1 on C# and the .NET Framework. Our next item, Lab 1.2, Using Visual Studio.